Hello, everybody. I'm going to disappoint Yanni right away because the whole purpose of my talk today is to convince you that React Server Components and GraphQL are a match made in heaven. Now, I'm Max, as Yanni said. I'm now the CEO of a company called Stellate, and I'm a software engineer, and I've done a lot of work in the React ecosystem. I co-created React Boilerplate, style components, a whole bunch of open source projects, and then later on founded this company called Stellate. And at Stellate, we've been really focused on building a platform that helps large organizations operationalize their GraphQL APIs. And we started with GraphQL edge caching, and then we added GraphQL metrics, and now we're adding GraphQL rate limiting and a whole bunch of other tooling around GraphQL APIs that takes advantage of GraphQL's really unique properties as an API to provide a whole bunch of value to companies. So if you're using GraphQL, come and find me afterwards. I am not going to talk about Stellate anymore in this talk. The big change that has come to Next.js and really the whole React ecosystem are React server components, right? And the really big deal about React server components is that now individual parts of your application can run on the server. Individual components can run on the server, which if you go back to look at the original RFC, which was, by the way, posted 4 years ago, which blows my mind, the whole point of this is that it allows you to do server things in your component. And the canonical example is to access your database, right? To go away db.post.get ID. Now, this is amazing, and it's a great developer experience when you're just starting out and when you're building something new. The problem is await DB in random server component somewhere doesn't scale. Now, before I go any further, I want to say for most of you, this probably doesn't matter, and you should do it anyway. As Kitze would say, I don't know if you're still in here, as Kitze would say, if your product only has one user, don't over-engineer it. Figure out how to get your product in the hands of more users. But if you're getting to a scale where you have 10 plus engineers on a team working potentially with microservices in the background already, and you have to scale up to a much larger audience, having random await DB calls throughout your whole application in random components doesn't work. It's essentially the same thing that people used to do with REST APIs at scale, where they ended up with hundreds, sometimes thousands of REST endpoints that all did various DB calls that were called from the client. And the problem with this is that performance becomes an issue, because you end up having all these various places where all these random DB queries are made. And so if you're, for example, adding an index or having to change the way your database is queried to improve performance, you now have to go through all those places to update the database queries. It's a huge pain in the ass, to be honest. The other part that often becomes a problem is security. If you have random database calls in random server components, who's checking all those database queries to make sure that they're not accidentally exposing data that they shouldn't? Particularly with React server components, they essentially create implicit endpoints that send data, right? If you're passing an array of objects to a client component, that whole array of objects will be sent over the network to the client and will be visible on the client in the source code, but maybe nowhere else, even if the client component doesn't use all of that data. And so you could accidentally be exposing data through those implicit RPC function calls that you might not want to expose. And right now, Next.js actually doesn't have a lot of tools to prevent this. You could very much run into security issues exposing data that you want to pretty quickly. And then the third is that nested server components can cause waterfalls, because if you have await DB queries in all of your server components, then if the outer server components first awaits DB and then the inner server component awaits DB, the second can only run after the first has completed. And what I mean by that is, for example, imagine a user profile component that instead of getting a user, does an await db.users.get ID and then renders the user data from that server component. The problem you run into is if you render multiple user profiles on a page that maybe depend on, for example, loading the blog post first, you now have a loading waterfall. You have to load the blog post first, then the user profile server component renders, and then it fetches the user, which is pretty slow. Now, there's a pretty simple way of fixing this, which is to architect your components such that they take in data. And then you load data as high up in your component tree as possible, right? And so in this case, we have a user profile component that just takes a user's name and bio and then renders the user's name and bio, but isn't concerned with actually loading the user data itself. And so if you can adhere to that, you can avoid waterfalls. Now, this still isn't ideal though, because you run into problems with which data exactly does this component need and where do I get it from? And fundamentally, even with React server components, once you're at scale, you really want some form of a central data access layer, some central layer that defines what data is available and how to get it, and where components can then define, hey, I need this data, please go get it for me. And the central data access layer figures out how to get that data. Now, that sounds very similar to an API. And in fact, APIs are a version of this. But if you think about React Server components already run on your server. And so having a separate API service that you then send a request to resolve data is essentially almost pure overhead, right? If you think about a homepage component where you have a fetch call to fetch a list of blog posts, if you think about it from an infrastructure perspective, the client sends a request to the server, then the server is already in the cloud, the server sends a request to the API, and then the API goes and talks to the database. That extra request from the server to the API is pure overhead, right? You don't really need it. It's a separate service for no real reason. It exists, but we don't need that request, right? Because theoretically, the server can talk to the database directly. Now, you still need an API, right? Not everybody does, but most people at scale do, because you might have client needs where they need to dynamically ping the API. You might have partners that want to integrate with your service that need to access an API, right? They don't have server components that have access to your database. You might still need an API, but that is a separate piece that your actual server components don't necessarily need to hit. Now, this is why I believe that GraphQL is a perfect fit for React Server Components. And in fact, React Server Components and GraphQL are a match made in heaven, because GraphQL allows you to execute queries in any JavaScript process, right? You can define your API and you can resolve the data, but where that query comes from doesn't have to be via a network call. Now, the problem with React Server Components and GraphQL is that doing it right and doing it well isn't super obvious. And also GraphQL generally has a bit of a tooling problem where there's too much tooling in the ecosystem and it's kind of hard to use well. It's hard to use correctly, and none of the tooling really guides you down the pit of success. And so that's why at Stellate, we built for our API a tool that we call Fuse. This is open source. You can go to GitHub and find it. And Fuse is a way to build and query GraphQL APIs as effortlessly as possible. And specifically, it's very optimized for this use case of, I'm using React Server Components. I need a data access layer that lets me just define what data is available and then get it as easily as possible. And at scale, you're often talking about a data access layer that sits in front of many different services, right? That could be microservices, that could be many different microservices owned by many different backend teams, but also it can be many different third-party APIs. It can be the Stripe API, it can be the Contentful API, it can be any number of data stores. It can be a Redis instance somewhere, a Postgres instance somewhere, a ClickHouse instance somewhere. Many different sources of data come into this data access layer, and then the client has to be able to query them as effortlessly as possible. Now, to go back to React Server Components, Fuse comes with React Server Component support built in. And what that means is that when you define a GraphQL query, like in this case, the homepage query that fetches the current user and the first 10 blog posts in a list, you can then await execute that homepage query. And rather than, for example, use query does, execute doesn't hit the network. It runs the actual GraphQL.js execution engine in the server-side rendering process to resolve the data as efficiently as possible without an extra network request. It just goes in the process, resolves the data, and returns it. Now, this await execute homepage query blows my mind because nothing changes about the way that I create or query my GraphQL API. It's the same code that I'm already used to. The only difference is in a server component, I just don't hit the network. If I want to use it from the client, I can hit the network via an API route. Now, importantly, when you build a data layer for React Server Components, you want it to be a slim as possible aggregation and transformation layer, right? I was saying how at scale, you have many different data sources that you're fetching data from, microservices via gRPC, other REST APIs, other data stores, Postgres, etc. Now, you want to spend the least amount of effort creating that data layer as possible, right? You want to take those sources and turn them into an API and a data layer that works for what you need. What's interesting is there's solutions for this out there today, right? You have things like Hasura that turn anything really into a GraphQL API for you. There's tools that do the same thing with REST APIs. What we've learned is that those tools break down at scale because you need to be able to aggregate and transform these data sources. You can't just take them, turn them into an API and use them on the client. Often the way they think about their data doesn't quite match what you actually need on the client. In fact, most of the time we find that 80% of the data gets exposed as is, but a solid 20% gets aggregated, gets transformed, gets changed, gets exposed in a different way and accessed in a different way than the database thinks about it, or the data stores or any backing services thinks about it. And so Fuse's whole API for building a GraphQL API is optimized for allowing you to do this as easily as possible. And so the whole API essentially is just like, where do I get data from? And how do I want to expose it? How do I want to transform it? What do I want to pass through? And what do I want to change, right? And so in this very simple code example, you can see how you can expose the product name as a name field. You can add a whole new connection to categories, which is another category node, to create a connected graph of your data, right? And those things could come from many different data sources. You could have a Shopify CMS that is responsible for all the products, and then your categories or your reviews could be coming from a completely different data source. And yet to the client, it looks like one connected API. And the only thing you really have to define is, what do I want to expose and what do I want to connect? How do I want to aggregate all this data? And how do I want to transform it so that the client can access it in the simplest and easiest way possible? Another core benefit of having specifically GraphQL for your React Server Components data layer is that you can do something called fragment composition. If we go back to the user profile component that we saw at the beginning, you can imagine in a large organization, in a large project, this user profile component is going to be used all over the place, right? It might be used on the home page to show the current user. It might be rendered on the blog post page to render the blog post's author, et cetera, et cetera. You can imagine many different ways that this component would be used because it's a reusable component. That's the whole point of the component, is to be reusable, right? Now, what happens if we now add the ability for users to upload avatars, right? Now we have to extend this component and have it take an avatar URL prop. And then now I have to update every single call site that uses this component to fetch the avatar URL of the user and passes it to this component and then renders it. That is possible, but it's a lot of menial work. It's a lot of updating things all over the place in various people's responsibilities. It's just kind of annoying and tedious. With GraphQL, this happens automatically. And what I mean by that is that you can define component fragments that define which data the component needs, right? And so in this example, we have a fragment here that says, hey, my user profile component needs the user's ID, a user's name, and a user's bio. And then the component says, hey, let me read that fragment from my props and render the user's name and bio in this case without the avatar URL yet. Now, when I use this component, I also have to fetch its data, right? And so if we go back to the homepage query that we had earlier, I now pass in this user profile fragment at the bottom of the homepage query and then spread the user profile fragment in the places where I need it, right? And so that user profile fragment in this example is now used to both fetch the current user information, but also to be fetched the blog post's author, both of which are user types, right? They're the same underlying type. And the homepage query doesn't even have to think about which fields, which data exactly does the user profile component need. It just says, hey, user profile, go get the fields that you need, and then I will pass that to you in the context of the data that I fetched, right? And so then further down below, when we actually render the user profile, we pass in user equals data.current user once, and then we also pass in data.blogposts 0.author once, right? But the homepage now has no context or idea of what data exactly the user profile component needs, and that's on purpose. Because what that means is, if we now go back to our user profile component and we add the avatar URL again, right, which is a one-line change to now fetch the avatar URL as well, nothing else has to change, right? The user profile component's change is now completely encapsulated within that component. We want to update our user profiles to render avatars. We make that change in the user profile component, everything else adapts automatically because the homepage just fetches the data that the user profile needs without knowing what exactly the data is, without having to care about what exactly that data is. And so this fragment composition model makes code evolution way easier, particularly, again, when you're at scale with many teams that have different responsibilities and different ownerships. The team that owns the user profile component can make this change without having to touch any other code by any other team. They make it in their file, in the thing that they own, where they want to make the change, and it just works everywhere across the board. And because it's GraphQL, it doesn't even fetch any extra data, right? It just fetches the data that it's supposed to. It fetches the ID, the name, the bio, and the avatar URL of the user. Nothing more and nothing less, which again, at scale is huge because these organizations have so much data that if you just think about a REST endpoint that returns one user's data, that can be dozens, if not hundreds of lines of JSON. But we only need these 4 properties, and so we only fetch these 4 properties, which is just one of the big benefits of GraphQL in the first place. Now, Fuse, we built this open source library and we optimized it heavily for Next.js, but you can also use it without Next.js to build and query a GraphQL API. You don't have to be using Next.js, it just has Next.js support built in. We also didn't reinvent the wheel. The GraphQL ecosystem has a lot of great open source tooling available that is awesome. And in fact, Fuse is essentially a collection of this open source tooling that is optimized for the specific use case of making it really easy to build these slim aggregation and transformation layers. And so it's really powered by some of the most popular tools in the GraphQL ecosystem, including Pothos, Urkel, GraphQL Yoga, some of the really battle-tested and scalable tools with some opinions built on top, that make it much better and more optimized for that specific use case. Now, getting started with Fuse is as simple as running one npm command. And I'm going to risk a live demo here and see if this actually works live. We'll see if the Wi-Fi holds up. Let me put the microphone in here. All right, I'm gonna unmirror my screen, and then we're gonna try setting up a new Next.js project from scratch and then add Fuse to it with one command. If I could unmirror my screen, please. Here we go. All right, y'all can see my terminal. Let me go back here. I just ran a test earlier so that I could make sure in case the Wi-Fi doesn't work, I have a backup. We're gonna run pnpm create next app. This creates a new next app from scratch. I'm gonna call this.
Minimize the window. That's kind of low on the corner.
Yep. Let me make it way bigger as well. And I'm gonna. Oops. Hello. There we go. Is that better? All right. Let me try that again. What is your project name? I'm just gonna call it Kongres demo. We're gonna use TypeScript. Don't care about ESLint right now. Don't care about Tailwind. Sure, let's use the source directory, app router, yep. Nope. All right, answered all the questions. This is now going to set up just a normal Next.js project from scratch, right? If I go into see the Kongres demo, let's make sure it works. pnpm dev, open up our, where's our browser here? Localhost 3000. We should hopefully see, Next.js, please work. Beautiful. Next.js works, awesome. All right, now I'm going to add Fuse to it. I'm going to run pnpm create Fuse app, which sets up Fuse with Next.js for me. It detects that I'm in a Next.js folder, and it sets up Fuse from scratch for me, including adding an API route for client components and setting up the whole API from scratch. This is going to take a little bit, and essentially what this is doing is installing a bunch of npm packages, adding an API route at /API/Fuse, and adding a first demo type, a first demo node called user, so that we have something to query against. Here we go. Beautiful. I hope nobody else was npm installing at the same time. Let me open up code here, and let me also run pnpm dev again. And if we go to localhost 3000 /API/Fuse, we'll have an API route for Fuse. And if everything's working well, famous last words, because it's not, we should be able to query a user. And we cannot. Let me see what didn't work here. We're going to open up code. Oh, I immediately know what didn't work. It didn't update the Next configuration. We have to import Next plugin Fuse from Fuse Next plugin, I think. And then we have to wrap our Next config with this Next plugin. I'm not sure why Create Fuse app didn't do that. I will log a bug report right after this talk. Let's try running pnpm dev again. Fuse Next. Maybe it's called something else. Live debugging. Next Fuse plugin. What did I write? Next plugin Fuse? Man, words are hard. Here we go. Yes, there we go. Okay. Now if we open up, we should be able to query for a user, except it doesn't have a bio field. Let's try that again. Boom. Okay, and we can now query users. So we now have a GraphQL API that has one user type. Let me also make that bigger. Let me show you what this looks like in the actual code. So what happened here was that for Fuse, the only thing you really need to do is add this Next plugin, and then we've also added an API route at API/Fuse. Now, you don't need to use this API route. If you just have server components that access data, you actually don't even need this API route, but this is really all it looks like. It just creates an API route handler for you in case you have the need of other customers, other clients, other partners wanting to integrate with your service, the client needing to ping you dynamically. You can easily create an API that is accessible via the network out of this. What does it look like to actually define this API? We have one demo type that was added here, which is a user type. And essentially, the core abstraction in Fuse is called a node. And so this user node defines how to load its data, right? How do we get a list of users, right? When we get a list of IDs, what does it mean to load a user, right? Now this get users function can be anything. That can talk to your database, it can talk to your CMS, it can talk to your microservice, it doesn't matter, it just fetches some users. And then we define, based on that user loading, what do we want to expose how, right? And so in this case, we're saying, hey, we just want to expose the name directly. We want to rename the avatar URL slightly to make it camel case. And we're going to add a first name field that just splits the user's name and adds the first, and so it uses the first part of it. Now, get users here is just a fake function that just returns some random data. But again, that could be anything. And so now we've defined a user type that we can query throughout our app. And so let's see what that looks like. On the homepage, I'm just going to add a query that says get user, and we got to import GraphQL from @Fuse. So Fuse has generated a whole bunch of files here at source/Fuse that have all the types that you need and all of the functions that you need to actually query your API. And so I can go in here and I can now go, actually let me select the TypeScript version to use workspace version, which should give me autocomplete here as well. I can now query for a user, and as you can see, I get full autocomplete, and not only that, this whole developer experience was set up for me. I had to use the workspace TypeScript version because that's something that VS Code requires me to do. But fundamentally, I now have full autocomplete within my editor. And this is all powered by a tool called GraphQL Tada that can parse GraphQL in TypeScript, which is kind of crazy. All right, and now how do we actually execute this? Again, we just go await execute, which we import from Fuse server. And then we're going to do query, get user, variables, and we want to fetch the user with the ID 1 for now. And that actually gives me back data and errors. Now, if I don't have data.user, I'm just going to return not found. Otherwise, I'm going to delete everything in here. I'm going to render h1, data.user.name. And I think that's it. Is there any other data that I have? Or the first name, I guess, but that's fine. All right, let's just render the user's name. I'm going to go up here, open localhost 3000 again. And what we should see, hopefully, is a user's name. Let's see if I did everything right. Peter number 1. So we just fetched, thank you, I appreciate the clap. We just fetched one whole person clapped. Thank you. Live demos are scary, let me tell you. The fact that this worked is amazing. So we just rendered the user number 1's data without ever actually hitting the network, right? I can delete the API route that Fuse added for us automatically at /API/Fuse, and this would work the exact same way because again, in server components, we have this await execute that doesn't actually hit the network. It just knows the GraphQL schema, it knows the GraphQL execution, and just executes the query that we defined against that on the React server-side rendering server in the same process without having to go via the network. Now, importantly, if this wasn't a server component, I could equally run use query, right? I could use query to fetch dynamically from the client and point it at /API/Fuse to fetch that data. So all that still works, but it is optimized for server components. Beautiful. All right, let me go back to my slides here. That is everything that I had to show you today. Please give Fuse a try, fusedata.dev. The repo is at stellate.hq/Fuse. If you're using server components, if you're at large scale, or if you're using GraphQL, please come talk to me. I would love to hear from you. I would love to answer all your questions. I'll be here all day. Thank you all for having me.